4. Probability. The words likely, possibly, chance are common in our everyday conversation. When we say India will have chance to win the Cricket World Cup means the chances of winning the cup are bright. When we say probably it will rain today, that means it will rain or it may not. The degree of uncertainty can be measured numerically with the help of probability. And for this, we should know the different terms used in probability. When we perform any experiment in the laboratory, the results are fixed. But when we toss a coin, the result is not sure. That means we may get head or we may get a tail. So such experiments are performed randomly and therefore these are known as random experiments. So in probability, mostly the random experiments which we are going to perform are first one with the help of a die. You all know this is a die which is having 6 surfaces and the numbers written there are from 1 to 6. So the set of numbers from 1 to 6 is called sample space and we write it as S is equal to 1, 2, 3, 4, 5, 6 in curly bracket. That means here we get 6 possible outcomes. So now you know outcome means the results of a random experiment. S is also known as omega. Now the another device which we are going to use is a coin. A coin is having 2 surfaces, one is head and another is tail. Head is denoted as H and tail as T. So when a coin is tossed, the sample space S is equal to HT. When 2 coins are tossed, the sample space S is equal to HH. That means both of them are having head. HT, one is having head, second one tail. TH, first one with tail and second one with head. And TT, both of them are having tail. Now the number of elements in the set S is denoted by NS. So when one coin is tossed, NS is equal to 2. When 2 coins are tossed, NS is equal to 4. And when a die is used, NS is equal to 6. Now next, we can use a pack of cards. You all know that the pack of cards is having 52 cards without joker. There are 26 red cards and 26 black cards. In red cards, there are 13 heart cards and 13 diamond cards. In 26 black cards, 13 are black club cards and 13 are spade cards. That means heart, diamond, club and spade are the 4 suits, whereas 1, 2, 3 up to 10, then jack, queen and king are called as denominations. King, queen, jack are known as face cards. Remember, ace card, that is the card bearing number 1, is not a face card even if it is having a design. So remaining are number cards. Now we should know what is meant by equally likely outcomes. A given number of outcomes are said to be equally likely if none of them is expected to occur in preference to the others. The outcomes satisfying the particular conditions are known as favorable outcomes. Now, a subset of the sample space is called an event. A set of all favorable outcomes is an event. Now we'll see the types of events. First one, certain event. The event which contains all the sample points of the sample space is called a certain event. For example, when a die is thrown, it is a random experiment. Therefore, S is equal to 1, 2, 3, 4, 5, 6. That means NS is equal to 6. Let A be the event of getting a score less than 8. Therefore, A is equal to 1, 2, 3, 4, 5, 6. That means NA is equal to 6. Here, the event A contains all the sample points and therefore A is a certain event. Now another type is impossible event. An event which does not contain any sample point is the impossible or null event. For example, when a die is thrown, S is equal to 1, 2, 3, 4, 5, 6. That is NS is equal to 6. Now A is the event of getting a score on the upper surface is 9. It is not possible, therefore NA is equal to 0. In this case, A is the impossible event. Next is elementary event. An event consisting of only one sample point is called elementary event. Again we'll see the same die. S is equal to 1, 2, 3, 4, 5, 6. That is NS is equal to 6. Now A is the event of getting a score on the upper surface which is divisible by 5. Now here 5 is divisible by 5. So this event is having one sample point. Therefore A is equal to 5. Therefore NA is equal to 1 and event A is an elementary event. Now next is complement of an event. When a coin is tossed, S is equal to HT. Let A be the event of getting head, so A is equal to H. Therefore A dash is equal to T. Here A dash is the complement of A. Next is mutually exclusive events, that is disjoint events. When two coins are tossed, it is a random experiment. Therefore S is equal to HH, HT, TH, TT. Let C be the event of getting one tail. Therefore C is equal to HT, TH. And D be the event of getting both tails, so D is equal to TT. Now C intersection D is equal to null set, and therefore the events C and D are mutually exclusive events. Remember, two complementary events are always mutually exclusive events, but converse is not true. Now the next type is exhaustive events. Two or more events are said to be exhaustive events if their union is a sample space. Now A is the event of getting only one tail, then A is equal to HT, TH. And B is the event of getting both the heads and both the tails, then B is equal to HH, TT. Here A union B is equal to S. And therefore A and B are exhaustive events. Now we'll see the probability of an event. The probability PA of event A is equal to number of sample points in event A upon number of sample points in S. Therefore PA is equal to NA upon NS. The probability of an impossible event is 0 and that of certain event is 1, and therefore probability of any event lies between 0 and 1, both inclusive. So now the question is, a die is thrown, then find the probability of getting an odd number. If we throw a die once, the possible outcomes are S is equal to 1, 2, 3, 4, 5, 6. Therefore, NS is equal to 6. Let A be the event of getting an odd number. Therefore, A is equal to 1, 3, 5. Therefore, NA is equal to 3. Therefore, PA is equal to NA upon NS is equal to 3 upon 6 is equal to 1 upon 2. Next event is, let B be the event of getting a perfect square. Therefore, B is equal to 1, 4. Therefore, NB is equal to 2. Therefore, PB is equal to NB upon NS, that is equal to 2 upon 6, that is equal to 1 upon 3. Now next event is event C. Let C be the event of getting a number greater than 3. Therefore, C is equal to 4, 5, 6. So, NC is equal to 3. Therefore, PC is equal to NC upon NS is equal to 3 upon 6 is equal to 1 upon 2. Now the next question. If a card is drawn from a pack of 52 cards, find the probability of getting, first one, a black card. The pack of cards is having 52 cards and therefore NS is equal to 52. Now A is the event of getting black card. Therefore NA is equal to 26. Therefore PA is equal to NA upon NS, that is equal to 26 upon 52, that is equal to 1 upon 2. Now next event, not a black card. Now not a black card means it should be a red card because the pack of the cards is having only 2 colors. And therefore, let B be the event of getting not a black card. Therefore, NB is equal to 26. Therefore, PB is equal to NB upon NS, that is equal to 26 upon 52, that is equal to 1 upon 2. Now the next event, a card bearing number between 2 to 5 including 2 and 5. Let C be this event. So, from 2 to 5 means 2, 3, 4, 5, that is 4 cards. So there are 4 different suits, that is spade, club, diamond and heart. So the total cards will be 4 into 4, that is 16. Therefore NC is equal to 16. Therefore PC is equal to NC upon NS, that is equal to 16 upon 52. That is equal to 4 upon 13. Now we'll see about the addition theorem of probability. If A and B are any 2 events of a sample space S, then P of A union B is equal to PA plus PB minus P of A intersection B is an addition theorem of probability. Now the question, in a class of 100 students, 60 students drink tea, 50 students drink coffee and 30 students drink both. A student from this class is selected at random. Find the probability that student takes at least one of the 2 drinks, that is tea or coffee or both. Now the total students in a class is equal to 100 and therefore NS is equal to 100. Let A be the event that students drink tea. Therefore, NA is equal to 60. Therefore, PA is equal to 60 upon 100. Let B be the event that students drink coffee. Therefore, NB is equal to 50 and PB is equal to 50 upon 100. Now, A intersection B is the event of students who drink both tea and coffee. Therefore, n of A intersection B is equal to 30. Therefore, P of A intersection B is equal to 30 upon 100. To find the probability that students take at least one of the two drinks, the formula is P of A union B is equal to P of A plus P of B minus P of A intersection B. That is equal to 60 upon 100 plus 50 upon 100 minus 30 upon 100. That is equal to 110 upon 100 minus 30 upon 100. That is equal to 80 upon 100. That is equal to 4 upon 5.